In this video, we are going to discuss about first order low pass filter with unity gain. So you know that here it is first order means it has only one pole. Okay, one pole, and we are using active filters, that is op amp, which is having unity gain. So let us discuss the diagram of this one. So since it is a unity gain, for minus you have to connect like a voltage follower. Okay, and since it is a low pass filter, you have to connect a resistor and capacitor. So at this point, you know, this is V out, so this is also V out, right? So I can write V out is equal to 1 divided by SC, this capacitance divided by into input resistance divided by 1 by SC plus R. Okay, so I can write it as V in by 1 plus R SC. Okay, so what is V out by V in? V out by V in is equal to 1 divided by 1 plus J omega RC. If I substitute for S, J omega. Okay. So V out by V in is equal to 1 divided by 1 plus J 2 pi F RC. Okay. So I can substitute FH is equal to 1 divided by 2 pi RC. Okay. So if I substitute, I will get 1 divided by J, 1 divided by 1 plus J F by FH. Okay. So if I take magnitude of this one, okay, I will get 1 divided by root of 1 plus F by FH whole square. So here the n value is nothing but the 1. Okay, so you will get, since it is a first order, okay, 1 plus F by FH power. Okay, so this is nothing but your transfer function H of JF. So if I plot a Bode plot between F and H of JF, okay, since it is this value is at if F is equal to 0, it becomes 1, right? So this is 1, okay, and at F is equal to FH, it started to fall, right? That is, it is falling at rate of minus at rate of 20 dB per decade. Okay, or it can be written as 6 dB per octave. Both are same. Okay, it is not falling as steep as a second order filter. Okay, so this is nothing but your higher cutoff frequency. So at this point, it is nothing but 0.707. This value is 0.707. So let us discuss one problem on this one. So design a first order low pass filter. They have given the cutoff frequency as 10 kilohertz. Okay. And it is having unity gain. Okay, they have mentioned it as unity gain. Find the voltage transfer function. Okay, so they are asking about H of JF. So you know the formula, right? 1 divided by root of 1 plus F by FH the whole square. Okay. Find voltage transfer function at F is equal to 12 kilohertz. So this is a question. So you substitute the value. Okay, everything they are given. This is 12k and this is 10k. So if we solve, we will get h of JF is equal to 0.64. So usually we will take in dB. So 20 log of h of JF is nothing but minus 3.87 dB. So if so you can see in the if I want to get a steeper rate, you have to use the higher order. You have to go for the higher order filters. Okay. So next, let us discuss about first order low pass filter with variable gain. So if that is the case, this is the diagram. Okay, so since this value is, we know that this value is VB, VU is equal to VB into V, right? Since it is a non-inverting amplifier, I can write it as 1 plus RF divided by RI into VB, right? And we know that what is VB? VB is equal to VB is equal to 1 divided by SC V in divided by 1 plus SC plus R, right? So this is nothing but VB by V in is equal to 1 divided by 1 plus R SC. Okay. So you substitute this value, this first value in the second value. Okay. So if you substitute V out divided by V in into 1 plus RF divided by RI is equal to 1 divided by 1 plus RSC. So now I can write V out by V in. V out by V in, that is nothing but I can write it as H of S, that is equal to 1 plus RF by RI 1 plus SCR. This I can write it as A 1 plus J omega CR. That is equal to A divided by 1 plus J 2 pi F RC. So if I take modulus of H of F, okay, I will get A divided by root of 1 plus 2 pi F RC the whole square, right? So on this F H I can write it as 1 divided by 2 pi RC. So A divided by root of 1 plus F by FH the whole square. So if I draw the voltage transfer function for H of JF, this is your A, and that 0.707 of A, you will get the cutoff frequency, right? This is your FH.